Good day, Sir Jess. This is the final presentation of our methodology, and the title of our study is the characterization and isotherm study of the adsorption of sulfamethoxazole in an aqueous solution using modified activated carbon. So we are group 23, and I am John Ezekiel A. Resurrection.
I am Teresa Paula Borlongan.
I am Dane Kimberly Collado.
I'm Shanley Formelosa.
And our thesis advisor is Engineer Grace P. Upton. So for this presentation, we will roughly discuss what our group accomplished for the methodology part of our study. So aside from it, we will discuss the data that we have gathered and the next step that we will take regarding this data. So next slide. So our thesis objectives is first is to introduce the surface functional groups through acid modification for the better adsorption capacity of the activated carbon. So next is to compare the characteristics of both sulfuric acid modified activated carbon and the commercialized activated carbon without further modification. Third is to investigate the effect of concentration for the removal of sulfamethoxazole in an aqueous solution. And lastly is to determine the best fitting isotherm model that describes the interaction between the sulfamethoxazole molecules and sulfuric acid modified activated carbon.
The materials used in the experiment are the following: 2.5 liter of 95 to 97% analytical grade sulfuric acid, commercial activated carbon made from coconut shells, pure sulfamethoxazole powder. For the glasswares, glass funnel, 1000 milliliter volumetric flask, glass stirring rods, 250 ml glass beakers, glass petri dish, 2 ml glass dropper. For the equipment, analytical balance, pH meter, digital thermometer, and hot plate with magnetic stirrer. For the modification of the activated carbon, we weighed 5 grams of commercial granulated activated carbon in a 250 milliliter beaker in an analytical balance. Then it was mixed in a 200 milliliter sulfuric acid solution at 30 degrees Celsius. The mixture was stirred for 12 hours at a constant agitation speed of 250 rpm. After 12 hours, we filter the mixture and the acid-treated activated carbon is collected. The collected sulfuric acid modified activated carbon was washed for 4 times and each wash lasted for about 1 hour. The pH of the washing solution was determined, and this step was done until it reached a constant pH. The pH of the distilled water was also determined, and it was around 6.28. For the first washing, the pH of the filtrate was determined to be 1. For the second washing, the pH goes up to 4.64. For the third and fourth washing, the pH remained at 6, so at this time we already stopped the washing procedure. Finally, the modified activated carbon was oven-dried for a total of 3 hours, in which it was weighed each hour until constant weight is obtained. Initially, the modified activated carbon weighs about 4.58 grams. After the first hour of drying, the weight was determined to be 4.303. For the second hour of drying, the activated carbon now weighs 4.301 grams. Lastly, for the third hour, the weight of the activated carbon remained to be 4.300 grams. Therefore, at this rate, we already stopped drying the acid-treated activated carbon. For the preparation of simulated wastewater with sulfamethoxazole, zero point 0.1 gram of sulfamethoxazole powder was mixed with distilled water until the powder is dissolved. Then the mixture was transferred in a 1000 milliliter volumetric flask and is diluted by adding distilled water until the mark is reached to create a concentration of 100 parts per million. For the adsorption of sulfamethoxazole using commercial activated carbon, a concentration of 100 ppm simulated wastewater with sulfamethoxazole was mixed with zero point 0.5 gram of commercial activated carbon in a 250 milliliter beaker. The beaker was placed on a magnetic stirrer and was agitated at a speed of 250 rpm for 1 hour. After, the solution was filtered using a filter paper and the filtrate is subjected to UV-vis analysis.
Um, 100 ppm simulated wastewater with SMX is mixed with zero point 0.5 grams of sulfuric acid modified AC. Then after that, the solution is agitated for 1 hour with a constant speed of 250 rpm to allow fresh solvent molecules to continually be in contact with the solute. Then it will be filtered in a filter paper to separate particles or some unwanted components. Next is for the isotherm study. A total of 50 ml of simulated wastewater will be generated with SMX starting concentrations of 100, 200, 300 ppm. Then it will be combined with zero point 0.5 grams of sulfuric acid modified AC in a 250 ml beaker and placed on a hot plate with a magnetic stirrer for 60 minutes. The solution will be agitated at a constant speed of 250 rpm. After mixing, the solution will be filtered through filter paper, and the filtrate will fill the cuvette and will be analyzed with the UV-vis spectrophotometer.
So, as we finished the methods, we prepared the samples for testing. So, the commercial activated carbon and the sulfuric acid modified activated carbon was placed in a cryovial and were submitted to Admatel in Bikutan, Taguig City for Fourier transform infrared spectroscopy. So they have said that the results will be released after 10 to 15 working days. Next slide. So also the solutions for the simulated wastewater 100 ppm CAC, 100 ppm, 200 ppm, and 300 ppm SAAC were placed in a sterile container and these were submitted in NASAT labs in Cabuyao for UV spectroscopy. So also, the results will be released after 10 to 15 working days.
The last part of our presentation includes the data and analysis. As mentioned, two testings were done, FTIR analysis and UV-vis spectrophotometry. So after submitting the samples, we received the FTIR results approximately after 5 days. We received the requested soft copy of the report of analysis from Admatel via email. The report includes test description, summary of the results, remarks, and lastly, the FTIR spectrum of each sample. So the testing equipment used was the Perkin-Elmer FTIR spectrometer Frontier. For the technique, it was an attenuated total reflectance or ATR accessory So through the ATR method, the samples were directly measured for FTIR. The infrared spectrum is plotted between the range of 4,000 to 600 per centimeter, and the number of scans was 20. The remarks just state the validity of the report. The image of the samples as received was shown. The date of the testing, the name, and the signature of the analyst were also included. In summary, the infrared vibration spectra of commercial activated carbon and the modified activated carbon both contain silicon oxygen stretching bonds at 906.65 per centimeter and 899.61 per centimeter respectively. This indicates the presence of silicon compounds. The results unfortunately tells us that there is no difference between the commercial one and the modified one. To further understand, we have here the graph that shows the FTIR spectrum of each sample. The x-axis represents the infrared spectrum, which plots the intensity of infrared spectra. The peaks here, which are also called absorbance bands, corresponds with the various vibration of the sample's atoms when it is exposed to the infrared region of the electromagnetic spectrum. The y-axis, on the other hand, is the percent transmittance. As we can as we can see, there is a little to no difference between the graphs of the two samples. Both samples have peaks that range to roughly 900 per centimeter in their fingerprint region, and according to Admatel, the characteristic absorption of 900 per centimeters falls under silicon-containing compounds. For the UV spectrometry analysis, next slide please. We received the raw data after approximately 10 working days upon submitting the samples. And again, the data was sent to us via email. So here we have the graph that shows the maximum absorption of 100 ppm sulfamethoxazole simulated solution. In the graph, x-axis corresponds to the wavelength in nanometers. On the other hand, the y-axis corresponds to the percent absorbance. As shown, the maximum absorption was reached at 290 nanometer and 0.5981 absorbance. The data for the absorption capacity of both commercial activated carbon and sulfuric acid modified activated carbon is also shown in the table. Overall, the results just indicate that there is again little to no difference between the absorption capacity of the two. This leads us to the decision to redo the experiment. To further explain, we were able to complete and perform the experiment right on our indicated schedule. However, the results we got are somehow undesirable, and we are considering giving the experiment a try once again. Of course, this decision is supported by our thesis advisor. We frequently ask for the advice and suggestions of Ma'am Ria regarding this matter. So she instructed us to redo the experiment. So we will adjust some of the conditions in our methodology to get improved results. So what we will do is spend the rest of our days of this semester doing the experiment again. Rest assured that we will still do our best, and we are fully committed to finish the experiment, and we will be able to present our collected data in the final defense. That's all, and thank you.